we have determined the speed of a traveling wave in the medium equals the square root of tension over mass density for a string. We derive this for the normal modes, and we know that any solution f of x minus vt is a solution to the wave equation. Therefore, that v must be the square root of t over mu if it's the wave equation for this string. Those two things go together. So we're going to check that. So I have set up a string right here in the front, and it's basically clamped between two rods. That's this, and I've got it hanging off of a little mechanism so we can set a known tension in it. So hanging off of here is 130 grams right there. So it's going to have a tension T equals the mass 0.13 kilograms times gravity 9.8 meters per second squared. So the tension is 1.27 newtons in the string. The mass density is a little different from when we did our normal modes because I have less tension in the string, and the string is elastic. So when you put less tension, it bundles up more. When you stretch it really hard, the mass density goes down. So the mass density in this case, I've measured it, is 0.0039 kilograms per meter. Okay? And I've also put little flags on here. And they're spaced every 30 centimeters. I believe there are, yeah, there's 5. So you're going to be able to use that to see how fast the wave pulse goes by. So here, have a look at the string. You can see what I'm talking about. And now let's calculate then what is the velocity. So velocity is the square root of 1.27 over 0.0039. If you work that out, you get about 18 meters per second. All right. So let's see. So now I'm going to show you a pulse going down this string in slow motion. So there's your slow-mo video. Now, see if you can use that information and the spacing of the flags, 30 centimeters, to figure out how fast the pulse is going. So if you want to do that, do it now, because I'm about to give you the answer. So I have looked at it at a different camera, watching it at 30 frames per second, and when I did that, it went past 2 flags, almost exactly 2 flags, so 0.6 meters, 60 centimeters, and it did that in 1 frame. So 1 frame was 1/30th of a second, so I got 30 times 0.6. Sure enough, I got 18 meters per second. But definitely see if you get the same thing watching the slow-mo video.